Hello everyone. First, I would like to introduce myself. I'm Dr. Hany. I'm Assistant Professor of Architecture at the Arab Academy for Science, Technology and Maritime at Alexandria, Egypt. The research paper that I will present today is titled with Energy Efficient Retrofit Strategies at the Building Envelopes of Higher Educational Buildings in Mediterranean Climates to Achieve Thermal Comfort and Energy Efficiency. I will start by giving an introduction about the research topic. Global climate change has been a rising issue in the last decade, especially in Egypt. Greenhouse gases emission grew 133% from 1990 to 2012. Energy consumption in Egyptian public buildings is 9% of the total energy consumption in the building sector. Therefore, enhancing energy performance in higher educational buildings will have a significant impact on the reduction of electrical energy consumption and the nation's energy footprint. The International Energy Agency published a report stating that educational buildings consume high energy and therefore the retrofit is necessity. On one hand, the number of existing buildings is much than the number of new ones. On the other hand, the majority of energy used is by existing buildings, and the rate of replacement by new ones is very low, 1 to 3% yearly. Therefore, sustainable retrofitting of existing buildings is crucial to reduce energy consumption. Energy efficient retrofits would refer to the improvements done to a building to reduce energy consumption and improve its energy performance. Therefore, energy efficient retrofits for existing buildings are a necessity. Accordingly, this research will focus on energy efficient retrofitting of higher educational buildings envelopes in Mediterranean climate in Egyptian cities, as educational buildings are building types that consumes energy due to its building activities. There is a lack of application of energy-efficient retrofit strategies due to the lack of knowledge about the quantity of investment required and the potential of energy savings that could be achieved through energy-efficient retrofits in Egypt. Governments around the world have taken strong measures towards the energy-efficient retrofits of existing educational buildings in terms of improving their energy performance and internal comfort conditions to improve thermal conditions, resulting in the improvement of educational activities. Unfortunately, this is not the case yet in Egypt and in the Egyptian higher educational buildings. The research is intended to assess existing educational buildings to understand its energy performance and transforming it to energy efficient using retrofitting strategies to address Egypt's energy challenges. The study aims to present the potential energy savings in the existing building after applying energy efficient retrofit strategies using simulation tool through the following three objectives. First, to investigate experimentally energy efficient retrofit strategies to improve the indoor thermal comfort and reduce energy demand during summertime. Second, the case study is an example to promote and provide guidelines for energy efficient retrofit of higher educational buildings in Alexandria and other Mediterranean cities in Egypt. Moreover, the proposed work is suitable for a considerable number of higher educational buildings in Egypt which were built during the same time in 1990s and have the same building characteristics. Third, these concluded energy efficient retrofit strategies can be set as a legal measure for achieving energy efficient educational spaces, as it's essential to set code enforced retrofit measures to be implemented in Egypt. The research methodology. The research consists of two parts. The first part presents a theoretical discourse that reviews retrofitting existing building envelopes with a special focus on approaches found in different Mediterranean cities to address energy efficiency and achieve thermal comfort in higher educational buildings, while the second part is an experimental study applied locally in Egypt on a higher educational building. The literature review is divided into three parts. The first part shows different studies and research done by previous researchers on the building envelope, energy efficient retrofit strategies for educational buildings. It was concluded that there are most common retrofit strategies that were previously used, which are applying external thermal insulation layer, window glazing, and green roof application. However, there has little been done in this context of higher educational buildings in Egypt, where the typological features and use of pattern are different. Therefore, the paper will highlight the need to act on this particular typology. The second part will explain special aspects concerning retrofitting educational buildings, which are good indoor comfort and air quality, which are essential for appropriate educational development. The third part is concerned with the comfort requirements in educational buildings, which are thermal, visual, and acoustic comfort. They are key players for the comfort of educational spaces. The retrofitting process must consider and work to achieve those three variables. The study proceeds with an analytical part through analysis of 3 educational buildings in Mediterranean climate that had undergone through the building envelope retrofit actions in order to conclude the most commonly used energy efficient retrofit strategies, which are external application of external insulation of walls, the installation of double glazed windows, and application of green roof. These energy efficient retrofit strategies will be applied and stimulated in the case study. The chosen case study is the Department of Architecture Engineering building located at the AAST in Alexandria. It's built in 1996, consists of 4 floors. Here is a brief description about the building. The building has educational and non-educational zones. The building has brutalism architectural style with facades that are moderately designed. Existing building conditions are determined through building's energy audit, and a summary of problems are concluded, which are high indoor temperatures during the summertime. Educational spaces do not provide thermal comfort for students, which has a negative impact on the educational process. Case study methodological steps consists of 4 steps. Step number 1, a base case of the building is modeled and simulated using Design Builder. Step number 2, energy efficient retrofit strategies for the building envelope are investigated. Step number 3, the proposed retrofit variables are simulated and the building's energy consumption is calculated. Step number 4, comparative analysis between energy consumption of the base case and the case after applying retrofit strategies is conducted to find the achievable energy reduction. This table shows the 3 selected retrofit strategies with all their details: window glazing, insulation, application of green roof. The simulation results indicates the following. For the base case simulation shows the building consumes 175.5 kilowatt per meter squared. After the application of the 3 retrofit strategies, the building energy consumption recorded was 140 kilowatt per meter squared. By integrating the 3 previously mentioned retrofit strategies, energy reduction of 46.7 can be achieved. The research concludes with the following. The study is designed as a roadmap for energy efficient retrofit of educational building stock through the analysis of case studies of major significance in terms of building characteristics and period of construction in 1990s in Egypt, the recognition and the consistency of the existing higher educational building stock and the subsequent selection of buildings are representative of general conditions allowed comparing results and drawing from them energy efficient retrofit strategies that are applicable to higher educational stock in Mediterranean cities in Egypt. Thank you.